Hello. So here we are considering a firm with production function f of Lk is equal to 2L plus 3K. The input prices are W is equal to 3, so this is the price for L, and R is 2, so the price of K is 2. This is an example of a perfect substitutes production function. So what this means is there's going to be, we're going to have a constant MRTS. This means that we're going to substitute between these goods at these inputs at a constant rate. So for part A, we want to find the cost minimizing bundle of inputs that we can use to produce Q is equal to 20. So we want to produce Q is equal to 20, and we want to find the cheapest way of doing so. So what we want to do is we want to look at the MRTS between L and K. This is the marginal rate of technical substitution. So this is the derivative of f with respect to L divided by the derivative of f with respect to K. So if we just take these derivatives, I'm going to get 2 over 3. Now, in order to be minimizing the cost, I want to compare with the ratio of prices. So here we see that MRTS Lk is equal to 2/3. We also have that W over R is equal to 3 over 2. Here I'm just using the fact that W is equal to 3, R is equal to 2. So this means that the MRTS between L and K is less than W over R. So we just only use K. Because if the MRTS between L and K were greater than W over R, we would only use L. But here we see that the MRTS between L and K, which is 2/3, is less than W over R. So this means we will only use K. All right, so we're only using K. Highlight that. All right, so we're only using K, and we want to produce Q is equal to 20. So what we do is we need to have 20, so this is the amount we're producing, equal to f of 0 K. So we're solving for the K, which makes this true. So this requires that we have 20 is equal to 2 times 0 plus 3 times K. In other words, we could rewrite this as K is equal to 20 over 3. So the least expensive way to produce Q is equal to 20 is just going to be to use K equal to 20 over 3, L equal to 0. All right, so this is part A. Now for part B, we want to find the total cost function, the average cost function, and the marginal cost functions. Then, given those, we want to find the efficient scale of production. Okay, so we've already done most of the work here. So we want to find the total cost function, average cost? Yeah. So we want to find total, average, and marginal costs, and find the efficient scale. So what we need to do to find the cost function, we want to produce Q, and we need to find the cheapest way to produce this level of output Q. Now we know that the prices are still going to be 3 and 2. And the MRTS doesn't change, right? The MRTS is just 2/3 always. So we're always going to only use K here. That's the property of perfect substitutes. Based on these, since these prices are fixed, it was optimal for us to only use K. So we're only going to be using K to produce this level of 20. So I'm just going to write that here. Based on prices, it's optimal to only use K. So we have Q is equal to F of 0, K. So we're solving for the K, which makes this true. So we have Q is equal to 0, 2 times 0, plus 3 times K. In other words, we have, just like we had before, K is equal to Q over 3. Basically, same answer as here. I just plug Q is equal to 20 up here. But yeah, so Q, whatever I want to produce, if I want to produce Q, I'm just going to use Q over 3 units of K. So L of Q is equal to 0. K of Q is equal to Q over 3. So these are the amount of each input that you use to, whoa, that's not what I wanted. This is the amount of each input you use to produce level Q. Now, the cost function, that's the thing we want to find. This equals 3. So this is W. I'm just going to write these out actually. W times L of Q plus R, uppercase, R times K of Q. So this is W times 0 plus, I'll just plug in the values for W and R, even though it doesn't really matter. 2 times Q over 3. So this is equal to 2Q divided by 3. So this is the total cost of producing output level Q. Now what we can do is we can find the average cost. So the average cost of producing Q is just C of Q divided by Q. So this is going to be 2/3 Q over 3 divided by Q. This is just going to be 2/3. I'll do one more step. So it's going to be 2Q over 3Q, which is just 2/3. Okay. So the average cost of Q is just 2/3. Finally, we want to find the marginal cost. The marginal cost is just the derivative of C of Q with respect to Q. It's the cost of an additional unit of production. So we see here that the derivative of cost with respect to Q is also going to be 2/3. So the marginal cost is just 2/3. Okay, so now that's just the summary. We found the optimal quantities, the optimal levels of each input, given an output level Q. Using those, we plug those in, we found the cost function. Then, based on the cost function, we could find the average cost, where we just divide the cost by Q, we get this, and the marginal cost, where we just take the derivative of C with respect to Q. Now, it ends up being, in this case, that the average cost is equal to the marginal cost, and that's because the total cost is a linear function of Q. So, the derivative here is equal to the average cost over Q, but that's not necessarily always true. But worked out that way in this one. So now what we want to do is we're supposed to find the efficient scale. So the efficient scale is the quantity at which average cost is minimized. Now, this is kind of a trick question because the average cost is constant. It's a constant function. It's not changing as Q changes. So here, it's not really well defined. So there's no particular Q which minimizes this. It's just a constant average cost. So any value of Q minimizes AC. Note, this will not normally be the case. So just usually you won't have this, but just because this is perfect substitutes, it's just kind of an artifact of this. All right, so that is problem 2. I hope you enjoyed.